Hello, everyone, and welcome to this edition of our 7 Investing podcast. I'm 7 Investing founder and CEO Simon Erickson. Containers are taking over the software world right now. They're providing a new way for developers to more quickly build, test, and deploy new cloud-based software applications. But what are containers? Why are they becoming so popular? And what could they mean for us as investors? Well, I'm very excited to answer some of those questions today with my guest, Anand Khatri, who's a tech lead in a DevOps company, also an expert in containers. So I'm looking forward to exploring this topic a little bit more with him. Hey, Anand, thanks for joining the 7 Investing podcast today.
Hi, Simon. I'm glad to be here and excited to talk more about the containers.
Perfect. Well, you came very well prepared on it. You actually have a presentation that I'd like to spot up for anyone who's watching the video of this. Let's jump into that and we'll have kind of a back and forth conversation. But the first question I have, which is perfectly fit for your first slide, is what are containers?
Yeah, sure. Let me share my presentation. Are you able to see my presentation?
Absolutely.
Yes. So what is containers? So container is a standard unit of a software that packages up the code and all its dependency. So the applications can run quickly and reliably from one computing environment to another. And that's what containers are for. And that's where the containers are helpful. In containers, there are two major container engines that supports the containerization. One of them is Docker, and second one is a Rocket. Rocket is from Core OS. And in a slide, you will see how the containerization helps is like its whole unit packed inside this one container, and that needs everything to run the application. And initially, and the containers take the virtualization to the next level. Initially, virtual machine was the latest into the virtualization world. But virtual machine was more of the physical layer of the virtualization, whereas the container is more of the software layer of the virtualization. And that's what it powers up. It helps in general. Now, to explain in a very layman term, right? What in general world, what the container is used for and what is the best use is the container is used for separating into the one space and to ship it faster and reliable and scalable manner. And that is the exact fundamental that containerization doing in a software world, that it's easy to separate, easy to push faster and move faster to the production environment and deploy the code, test faster, and release cycles become very individual and more frequent. That says that Docker containers are there run on any operating systems? Then today's answer is yes. Docker containers runs on all the operating system, Linux, Windows, in your data centers, on your cloud. Even in a serverless architecture, the containers can run easily. Containers and the virtual machines have the similar resource isolation and allocation, but the functionality differently because containers virtualization at the operating system level and not the hardware level, and that are more portable and efficient for application that runs on the containers. Containers and virtual machines, we can see the in a diagram that, let's say if we have the one physical machine, right? And if you have to run multiple container into the physical machine and virtual machine, you can run the multiple applications or microservices into the one VM. While in the virtual machine world, for each application, you have to have the similar settings and codes or the libraries that you are running, and those are the code that can run together that we will discuss more into the next slide about the benefits of the containers, but and also the containers has now standard industry standards as well. And one of the industry standards is the Open Container Initiative, which known as OCI, and that helps the build the standardization into the container space. Also, Docker continuously contributing into the common project called Cloud Native Computing Foundation, which short form is CNCF in 2017. And the container D is the industry standard for container runtime. And that's how the container runs, applications runs, and it helps pushing application faster to the production environment.
Yeah, this makes a lot of sense on it. And so we've always heard that, like, if you're a software developer, you've already got your environment you want to work in, right? You want to work in either Windows, or you want to work in Linux, maybe if you're more open source. You want to work with Mac because you're familiar with it. But it was hard, right? It was hard to get all of that on the same page. Containers, it sounds like, is offering a lot of more freedom to develop things in the way that you want to without the interdependencies, without it screwing everything else up. Is that a fair assessment of where we're going with this?
Yes, exactly. It's very easy and flexible for the developers, because essentially developers doesn't need to worry about my application is running onto the Linux, Windows, or Mac. As long as they are containerized and the operating system supports the containerization, they are good to go.
And microservices, you mentioned that too. I immediately think of Netflix when we hear microservices. And we'll talk about the companies later on. I don't want to jump the gun too much on this. But is this what is the impact? Maybe this even brings me into the next question of, like, how is this changing the way that software is developed, or what is the kind of problems that this is solving now that you can have more individual efforts?
Mm-hmm. So microservice is helping in many ways, and yes, you are right, because Netflix was an early innovator and adopter in terms of the microservices, but then into the software world, it became the common ground for using the microservices. So what happens in the microservices is your applications is divided into the small logical components. Say, for an example, your website or your web application or mobile application has a sign-up process. Then there will be a authentication. That will be a completely separate microservice, authentication and authorization. That microservice takes care only about the authentication. And then your another web application or web portal has some other functionality that will be completely separate. Then if you have the session timeout or logout, that will be completely separate microservices. The benefit of the microservices is, let's say, if I have multiple teams in working onto the same applications. If one microservice, authentication microservice, makes some change, it will not impact any other microservices into the applications. If something goes wrong, only that microservice will be impacted, not the entire application. And that is the benefit of. Plus, it will become more individualization and more independent. So since it's a more granular and independent unit, you can work individual and push it faster and more frequent updates into the application set. And that helps building new features and functionality on your mobile application or web applications faster.
Perfect. So each one of the microservices can kind of be built independently rather than there being a weakest link that's holding down the entire application at the end of the day.
Yeah, okay, it's not great. Like a whole, like a mumbo jumbo burrito kind of legacy application where every code base is sitting into the one package. No, not anymore in a microservice world.
Gotcha. Okay, and now the next topic that you wanted to talk about was what are the problems that containers are truly solving out there?
Yes, correct. So what are the problems that containers really solves, and why industry is taking this and adopting it faster than normal, right? So one of the main important problem that Docker is solving is compatibility of each services or libraries and dependencies. Say for an example, you are one of the microservices running on Java 10. If one microservice is running on a Java 11, how would you run those applications into the same VM? There's no way. For those two microservices, you need a separate VM. Over here, if your application is Dockerized, you can take the Docker image of Java 10 and build the application and build the Docker image and run the container. And you can take the Java 11 version, build the microservice, build your code base on top of it and run those containers into Java. And both the containers can run into the same virtual machine. You do not need additional virtual machine. And that helps minimizing the cost of the virtual machines and compute, especially into the cloud world. If we go into the compute, it will minimize the cost of the compute and also gives the flexibility to run the applications. Another major important problem that Docker is containers are solving is each service has and managed its required OS dependency itself and bundled and isolated in its own container. So if one container is vulnerable, for an example, it will not impact another containers or subsequent containers into the same VM. That problem exists only into that container. So that helps into the isolation, but also help into the separation as well at the same time. Another major important problem that it's showing is compatibility of each service and libraries and dependency of the OS. So if one library or one service requires certain version of the OS, they can have that OS, different version of the OS, and another container can have a different version of the OS. They are all independent. They are not in dependency. If it's in a dependency, let's say if you upgrade the operating system version, if it impact the another one app, it solves the problem for one application but creates a problem for another application, it will not be helpful. It will not help developer to move faster or the organization to deploy the features and functionality faster. But because of this, you can do the upgrade independently. Also, change the component without affecting other services. If you are releasing one microservice or one service or one library, it will not impact the other microservices or other libraries into your applications. That is the one biggest advantage. And also the change underlying OS without affecting any of the service. Because since it's a OS is also separate, it's lightweight OS, so it will not impact or affect any of the other microservices in your application at the same time.
Yeah, it sounds like it's improving a lot of the compatibility issues that were legacy withstanding. Anand, I got a sneak peek as you showed the graphic on the next slide here. I was wondering if you could pull that up to just kind of connect everything together. I know that Kubernetes is another term that's being used a lot right now. It's the orchestration system itself for containers. Can you tell us a little bit about how all of this works together?
Yeah, sure. So before I go ahead and explain this into the diagram, what I would like to say is if your application runs in a container, running a container is not easy because container can die, container can terminate. It's very headache and tedious task for the engineers and developers keep the containers up and running all the time without affecting the applications. And that's where the container orchestration tools are very important. And one of the most adopted container orchestration tool is Kubernetes. And Kubernetes originally found in it's an open source project, but inside the Google, they are supporting the open source project of the Kubernetes. And Kubernetes was running in a Google since 2008. Their internal system called Borg was their internal system in the Kubernetes. That was built on top of the Kubernetes. The good thing about some of the advantages of the Kubernetes is they have the self-healing capabilities. So if your application runs in the containers, and let's say one of the container dies, then what will happen is Kubernetes will know that one of the container dies, it automatically spins up the container by itself. You don't even have to log in or do anything. The engineer doesn't even need to know. It will automatically spins up. Easy to scale up, scale down. That also helps. Let's say on your certain days or time of the year or month, you have more traffic on your website. You don't have to worry about, oh, I need to put more hardware into it, or how can I scale it up? It easy scale up. You just have to mention, well, you deploy the application in deployment.yaml file, you just have to mention your min replica and max replica. What is the minimum replica and what is the maximum replica? So in the event of any traffic changes, it adjusts it by itself. And that is the very powerful concept. And that also helps to reducing or adjusting the cost at the same time, because when there is more traffic for high demand websites, you want to spend more because you want to sustain the traffic. You want those customers on your portal. You don't want to let them go away. So you are okay to spend a little bit more money. So you can adjust that cost easily, because as you scale up, it will cost a little bit more, but you will get more traffic, right? And as soon as that time goes down, it automatically scales down to whatever the min replica is on your deployment.yaml file. And those are all configurable, easy to deploy. And that is what makes the Kubernetes powerful. Now, let me explain this diagram so that we know what are the components involved in this one, right? In Kubernetes, there are two major things: Kubernetes master and Kubernetes worker nodes. And whenever you see the Kubernetes managed service, in the world of Google Cloud, it's a GK. In the world of AWS, it's a EKS. And in the world of Azure, it's a AKS. Those are all managed, so Kubernetes managed service, where all the Kubernetes master node is under their control, and worker nodes are onto the user's control or their customer's control. And when and in the very overview of the Kubernetes cluster is, you see there is a deployment. That's where you define your deployment configurations into it. And based onto the deployment configuration, it will deploy your applications and containers. And these are the pods. Pod has a containers and sidecar containers and attached to volume. Volume is basically for storage. It attached to it. And on top of it, this is basically becoming one building block of one of my microservice. When I say service, microservice service or libraries. And it has an internal IP address, and this is the service number 2. So Kubernetes also provides the internal communication from service 1 to service 2. For service 1 to communicate to service 2, they don't need to go to the internet and communicate it out. They can directly communicate internally. And that makes the communication a little bit secure, because if you create the private Kubernetes cluster, and if you keep this communication private, this communication becomes more secure. Then it goes out to the internet and connect to the service. And if, let's say, if you have exposed the service to the internet, you can put the external URL, which is called ingress in a Kubernetes world. And that ingress is accessible to the outside world, or integrated into the applications, where applications use this for their compute purposes or for that microservice purposes. And this ingress will be accessible. Now, in this one, in terms of the security layer, there are a lot of security will be placed into it. All these ingress will not be directly accessible. You have to go through the API gateways. And those API gateways are secure API gateways that you have to use it. Also, the communication should be the TLS, transport layer communication. And that is a secure communication as well. Also, you can put a lot of identity and access management over here and ingress to see what is the traffic. You can diagnose that traffic. And if you recognize any uneven activity on your applications, you can directly catch over here at the first line of defense. Also, it comes firewall on top of it, and that makes your applications secure running under the Kubernetes cluster and as a container. And there are some of the containers require a sidecar containers. Say, for an example, my microservices need to access to my secret management. How they can, what you can do is you can put the agent, or let's say, for an example, my microservice needs to be monitored and I need to install the Datadog agent into it. You can put that into the sidecar container, and you can put that agent into this container, and that agent will continuously monitor and send the data back to your Datadog dashboard, and you can monitor those microservices very closely and effectively.
Yeah, I love this graphic. I mean, so starting at kind of the bottom and working our way up on it. So we've got individual containers, right? We've got kernels or nodes or things that are kind of at the individual level, but they're not always working well, right? Sometimes the code fails to execute. There are problems with them. They terminate over short periods of time. You don't want to have that public facing or impacting the entire application. And so like you mentioned, you've got agents that are constantly monitoring for anything that seems out of place. If something breaks, you've got kind of an orchestration system that says, okay, hold on, don't take everything down for me. And then you've got ways that you can scale those up or down based on the traffic requirements and spikes that you're hitting your website with. But then over time, we're individually optimizing each one of these nodes, right? Each one of these containers. We're building out an entire software application so that when it's ready, we can now have it publicly facing. We can have an application that's usable. Is that a fair assessment of what's going on in this graphic?
Yes, that is exactly the fair assessment and correct understanding about how the container works.
Could you talk a little bit about the challenges of using containers and how those are being addressed as well? This sounds very innovative and a more optimal way to build things at a microservices level. Are there things that still are pain points that are being worked on right now?
Yes. Initial version of the pain points was like lack of the container orchestration tool, running containers onto the bare metal server. Of course, running a container in bare metal server is faster, but very difficult to manage. And the container orchestration tools makes life easier for the engineers, DevOps engineers, developers, SRE, site reliability engineers, and support engineers.
And by bare metal, you mean your own dedicated servers, things that are working directly for your own applications, correct?
Correct. Yep. Now, a lot of those pain points is solved by the container orchestration tool, but it doesn't mean that now it's all nice and glory days, right? There are still some challenges into the containers. Say, for an example, one of the things that is challenging is what if you have to run the database into the container. If someone asks, can you run the database into the container? No. As of now, there is not a way to run the database into the containers because database require the more transactional basis and backup recovery options and those kind of functionality. Regardless, it's no SQL database or SQL database, but they need all those functionality. And if your applications into those containers, you cannot do that. That is one of the challenge that software engineers has. They cannot run the database in a container. Though if it comes in the future, I will not be surprised by adding more and more functionality and features into the containers. Another thing that is pain point is that if you bring the container orchestration tool into the picture, and what if your entire master node or master architecture of the container orchestration goes down? It immediately goes down all your applications. So that is also a risk to manage that master of the container orchestration tool. And that is the reason that all these Kubernetes managed services are coming along. along and as an offering into the cloud is because it's not easy to run those Kubernetes cluster by itself into the bare metal. You need that level of expertise and knowledge in-house. And not all the companies can do that. And that is the reason Google, Amazon AWS, Microsoft Azure, they have those expertise in the house. They are managing the master. They are make sure that their master nodes can keep up and running all the time. And that is the reason they are also providing the SLA and SLI, service level agreement and service level. Those are the things they are providing. 3 nines, 4 nines SLA they are providing, and that become more believable. And that's where the companies like smaller companies or medium-sized companies are starting to adopt it, because that they don't have to manage the master. So most of the headache goes away. What they can do is they can make the application containerized and just push it to the production and into the Kubernetes cluster and easy to run. Also, another thing is the certain type of the metrics is also very important to get it. And companies, especially the companies who are into the very strict regulations, they need additional level of the metrics. So to get those metrics also, sometimes it becomes challenging. And those are the challenges still exist, but the day by day it's getting bigger and better, I would say, every day. On top of that, one of the things that on top of the Kubernetes is coming is the service mesh. So you are saying over here it's service 1, service 2, right? So on top of that, you can put the service mesh, which is the mesh layer, and you can combine and you can run the service into any cloud. Doesn't matter, even if it's a private cloud or public cloud. You can run it anywhere and seamlessly without even impacting, and customer would not even know where your service is running. And those are the level of research and efforts are going on currently. And I'm super excited about those efforts because that makes engineers' life very easy. But the adoption of those things are still very, very minimum at industry level. But over time, it will get bigger. The adoption of those tools and technologies goes high.
Can you talk more about that? Where do we stand in terms of adoption of how many organizations are using containers?
So in a cloud market share, overall cloud market share is currently standing between 4 to 5% of adoption. Then the container adoption is less than 0.5% currently into all the industry, not just one industry. This is overall industry target. So you can see how big this impact can be and how bigger it will go. And it will get bigger, along with it will get better, because as soon as it gets better and better, people will start adopting it. It will become very easy to adopt and run it on the production environment. And that's where the container adoption will become more powerful over a time. We are still into the early days of the containers. If I can tell, if cloud, we are in a stage where cloud was in 2012, 2013 timeframe. So that's where we are currently at the containers adoption. We are that early in the game.
Well, cloud computing certainly did rather well for investors over the next 8 years. If we're in the early days of containers, just like cloud was back in 2013, that is something we should be paying attention to.